Hello students, today we will be learning about Venn diagrams, and this is a subject that you guys have already probably are familiar with and have covered in elementary or middle school, so this should be a pretty easy lesson. So first, here is your traditional Venn diagram. Our population of interest is 20-year-olds, and we're looking to see whether or not they go to school, have a job, or do both. So as we can see here, there are 0.35 of 20-year-olds go to school but do not have a job, whereas there are 0.2 20-year-olds who have a job but do not go to school. And then in the middle are 0.05 who have a job and go to school. And the number outside right here is 0.4, and that represents the students that the 20-year-olds that do not go to school or have a job. So here's our question. What is the probability that a randomly selected 20-year-old who goes to school also has a job? So we are going to be looking at conditional statements. Because we want to find the probability of a 20-year-old having a job given that they go to school, or probability of J given S, the conditional probability formula shows as follows. Feel free to pause the video right here and try to come up with a formula by yourself, and then unpause and see if you got it correct. Okay, so the formula is, the probability of having a job given that you go to school is the probability of having a job and going to school over the probability of going to school. And this is how you would solve the problem. So the probability of having a job and going to school is 0.05, as we mentioned above, in the middle right there. And the probability of going to school is 0.4. As you can see, you don't see a 0.4 up here, but you have to count the entire circle of school. So 0.35 plus 0.05 gets you the entire probability of 20-year-olds that go to school. And then you just plug it into the formula. So you see on top you have the probability of them going to school and having a job, and then over the probability of just going to school, and you would get 0.25. So you would conclude that 12.5%, or there's a 12.5 chance that a randomly selected 20-year-old who goes to school also has a job. So that was pretty simple. Next we will be moving on to tree diagrams. So tree diagrams are probably a new concept that you have not learned yet, but they are extremely helpful in statistics for figuring out problems, I guess. So we're going to be looking at candles versus air freshener and clean scents versus food smells. So everyone wants their house to smell nice, but a lot of people have different ways of doing it, and we're going to be looking at the probability of people having candles versus air fresheners, and if they like clean scents like flowery smells or like clean cotton or clean linen, versus food smells like some people like their house smelling like cookie or apple pie or oranges or strawberries, etc. So this is our tree chart. Oops, let me cover that. Alright, so you start at the beginning. There are two arrows that can go either way. So people that use these, there's a 0.63% that they will either use candles, or 0.37 of them like to use air fresheners. And it's important to note that any time you have these two arrows coming out, when adding them together, you should always get a sum of 1. So that's important to know. So say 63% of our population uses candles. Now we have to determine if they like clean scents or food scents. It says here, according to our study, that 78% of them enjoy clean scents and 22% of them enjoy food scents. Again, notice that 0.78 plus 0.22 equals 1. down here, it says that people that use, the 37% of people that use the air freshener, 57 of them prefer clean scents, and then of that, 43% prefer food scents. So, how do you solve a problem using this? I hope that was self-explanatory, by the way. If not, pause the video and ask your teacher if you have any questions. So that was the setup, and how do you solve it now? So you will be using multiplication to solve this. So say you want to find out the probability of someone using candle and they want a food scent. So you want like an apple pie candle, or the probability of someone getting a candle and having food scent. So you multiply. So you get 0.63 times 0.22, and that will give you an answer over here. Say you want to find out the probability of people that use air fresheners and like the clean scents. So you would take, so you go from here, multiply, go to air freshener is down here, 0.37 times cleaner food, clean, times 0.57. And then I've solved all of them for you up over here. So again, so the probability of having candles and then clean scents, 0.63 times 0.78. That gives you your answer there. Same thing here, candles to food, 0.63 times 0.22 equals your answer. Down here, goes down to air freshener, clean, so clean air freshener, answer, and then the same down here. And again, it is also vital to note that all of these answers that you get here, the sum of them should also be 1. Okay, so you know how to find the probability of going down, I guess, the arrows. But what if you want to find the probability of, say, okay, so say you really like clean candles. What if you want to find the probability of people that have clean candles and clean air fresheners? So to do that, you would take these numbers, or whichever one corresponds, and you add them. Do not multiply, add. Over here you add, over here you multiply. So you want to find out probability of clean candles and the probability of clean air fresheners. So you would add the two. So clean candles is 0.4914 plus clean air fresheners 0.2109, and that will give you the probability of people that like clean candles and clean air fresheners. I hope that lesson wasn't too hard for you. Again, if you have any questions, pause the video at any. You could have paused the video at any time to ask your teacher, and yeah. So I hope that was an easy lesson, and have a good day. Bye.